Okay, so we will define a linear system of equations in n unknowns. In general, looks like y1 is equal to a11 times x1 plus a12 of x2 plus dot 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 plus a1n of xn. That's the first equation. The second equation looks like y2 is equal to a21 of x1 plus a22 of x2 plus and so on, all the way to a2n of xn. And this goes on until we get to the mth equation. And we have m1 of x1 plus a m2 of x2 plus dot 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 plus a mn of xn. There are, in this case, m times n coefficients. That's the aij. And there are n unknowns, which are the x sub j. And here I can vary from 1 all the way to, well, there's 1, 2, 3, all the way to m. And j ranges over 1 all the way to n. This is what it looks like in general. And when we solve a system of linear equations, we are trying to find what values the xj's must be. So what does this look like in the real world? Well, here's a textbook example. There are 27 apples and oranges in a barrel, and twice as many apples as oranges. So how many apples and how many oranges are in the barrel? You might want to pause the video and try to work it out for yourself. First, I'm going to set it up, and if we let x and y be the variables, the unknowns, then together there has to be 27 of them. Okay, now we have to make a choice. What is the apples? Let's say twice as many apples as oranges. Let's let x be the apples, y be the oranges. So if we double the number of oranges, it's equal to the number of apples. Okay, so now we just have to solve this for x and y. So you might want to pause now. I will just recklessly go ahead. And this is equation 1, equation 2. We can plug equation 2 into equation 1 to eliminate x. So that means we get 2y plus y is equal to 27. So doing basic arithmetic, that's 3y equals 27, and that means that y has to be equal to 9. Now we can plug y equals 9 into equation 2. So we get 2 times 9, or 18, is equal to x. And that gives us the number of apples. And y equals 9 is the number of oranges. Okay, so that's one example. The other you might find more often in a textbook. Just generically, what is the solution to 3 equals 2x plus y? This is equation 1. 6 equals 2x plus 2y. This is equation 2. 1 equals x plus 3y, and that's equation 3. Now, what we can do is we can add or subtract multiples of equations to each other. For example, we can take equation 2 minus equation 1. So we get 6 minus 3 is equal to 2x minus 2x, which is 0, plus 2y minus y is y. Right? We'll call that equation 4. And that tells us that y has to be equal to 3. Now, we can plug it into any of these equations and see if we get a consistent system. If we plug it into equation 1, what happens? We end up with 3 equals 2x plus 3, but that would mean x is equal to 0. But if we plug it into, say, equation 3, we end up with 1 is equal to x plus 9, or x is equal to minus 8. What's going on here? Well, this tells us there is no solution because we're getting inconsistent answers from trying to solve our system of equation. We get x is equal to 0 and minus 8, but 0 is not minus 8. There can be no solution to this. And that's because we have an inconsistent system of equations. So that's pretty scary. How do we know that a given system of equations will have a solution? We kind of have some sense of how to find them, which is to just add and subtract multiples of the equations to each other until we eliminate some of the variables, and we could solve for the variables one by one. But we have to be careful that a solution actually exists. Just because we get an answer does not mean we get the correct answer. So we have to work through and make sure that our equations make sense and that our answers actually fit these equations. If they don't solve the equations, the system is inconsistent and there is no solution.